Good morning everyone. I am Meenakshi from Rohini College of Engineering and Technology. Today we are going to see the topic digital signature comes under the course cryptography and cyber security. Digital signature is one of the important application of public key cryptography. Hope you remember public key cryptography is the cryptography where we used two different keys for encryption and decryption. Usually, to protect two parties from the third party, we are using the technique called message authentication. That is, we can protect A and B from C with the help of the message authentication. But the message authentication cannot protect the communication between A and B against each other. Okay, that is, we cannot protect A from B as well as B from A, because anyone can send a fraud message or anyone can deny the creation or anyone can deny the reception. Okay, that's why we are going to the new topic called digital signature. It is very same as the handwritten signature. So usually in a document, why we are putting a signature? To verify ourselves and the date and time and the contents which are present in that document. Okay, so for the same purpose we are using a digital signature. It is the signature created digitally. It provides a set of security capabilities. Okay, so every digital signature should satisfy the following three properties. It must verify the author, the date and the time of the signature, and it should authenticate the content at the time of the signature, and every digital signature is verifiable by the third parties. The digital signature function includes the authentication function also. So this is the digital signature model. Bob wants to send a message to Alice. So he is having a message and he creates the signature by using any one of the digital signature generation algorithm. So for that he can use his own private key. Thus he gets the signature and the signature is added with the original message and it is transmitted to the receiver. At the receiver end, Alice again uses the digital signature verification algorithm, and for that she uses the sender's public key, and she verifies whether the signature is valid or not. So we will explain in detail. So Bob is having the message, and by using any one of the hash function like SHA algorithm, MD5 algorithm, he can create the hash code. The hash code is encrypted by using Bob's private key. Thus the signature is created. It is appended with the original message and it is transmitted to the receiver. So the receiver Alice gets both the signature as well as the message. So again she applies the cryptographic hash function to generate the hash code. At the same time she decrypts the encrypted signature by using the sender's public key. This is the decrypted signature. Now she compares both the calculated hash code as well as the decrypted signature. If both are equal, then the signature is valid. So DSA, that is digital signature algorithm, it is the US government approved signature scheme. It is used to provide the strong signature, and it is published by NIST, and it is the standard which is known as FIPS 186, that is National Institute of Standards and Technology published Federal Information Processing Standard FIPS 186. It is known as digital signature standard. So this digital signature standard uses the hash algorithm which is known as SHA, that is secure hash algorithm, and presents the new digital signature techniques that is known as digital signature algorithm. DSS was originally proposed in the year 1991 and it was revised in the year 1993. The main use of DSS is to provide only the digital signature function, and it cannot be used for encryption and it cannot be used for key exchange like RSA. But still it is a public key cryptography technique. So now we compare with the DSS approach and RSA signature. First we see about what is RSA signature. So we have the original message. By using the hash function, the sender creates the hash code. The hash code is encrypted using RSA algorithm. For that, we are using the sender's private key. The encrypted hash code and the message is combined and it is transmitted to the receiver. At the receiver end, the receiver again calculates the hash code and she decrypts the encrypted hash code by using the sender's public key using the RSA algorithm. Now, the decrypted hash code and the calculated hash code both are compared. If they are equal, then the signature is valid. Okay. So like that you can use RSA signature, or otherwise we can go with DSS, that is digital signature standard. So this one is DSS approach. From the original message, again the hash code is calculated, but to create the signature function, I am having a separate function called signature function, and to verify the signature, I am having verification function. So the signature and verification function uses several public parameters, and the signature is created by using a random key and the sender's private key. Now the signature consists of two components, S and R. It is appended with the original message and it is transmitted to the receiver side. At the receiver end, again we have calculated the hash code, and from the signature component S and R, okay, we are verifying, and by using the global public parameters we are verifying the signature. Once again the components are created and re-verified. Okay. So we will see in detail. Digital signature algorithm, that is digital signature standard, proposes a new technique called digital signature algorithm. It creates a 320-bit signature and it works with 512 to 1024-bit security. It is smaller than RSA and it is also faster than RSA. So it is used to provide only the digital signature. It cannot be used for encryption like RSA. So here also the security of the algorithm depends on the difficulty of computing discrete logarithm. Okay. So that is like RSA. This algorithm also depends on the difficulty of computing discrete logarithm, and this algorithm is a variation of Elgamal and Shannon schemes. Now we move on to digital signature algorithm key generation. So to generate the key, we need several public key values P, Q, G. So where P is the large prime number and Q is also a prime number, but it is a prime divisor of P minus 1. That is Q divides P minus 1. By using P and Q, we can calculate G. So the formula for calculating G is G equal to h power P minus 1 by Q, where h is any value which lies between 1 to P minus 1. Okay. So thus we have shared the global public key values P, Q, G between the sender and the receiver. Now each user chooses his private key and they have calculated their public key. For example, the randomly chosen private key is X. X should be less than Q, and from X he can calculate his public key, that is the formula is y equal to G power X modulus P. So what is G? In the previous step we have calculated, it is one of the global value which is shared between the sender and the receiver. Okay. So that's about DSA key generation. So now we move on to DSA signature creation. So we have 3 steps in every digital signature algorithm. One is key generation, other one is signature generation, the other one is signature verification. Okay. So the second step is DSA signature creation. To sign the message M, the sender generates a random key K. So K should be less than Q, and K is the random value, and every use we have to destroy K. We cannot reuse K. Okay. So then by using K and the global values, we have computed the signature pair. As I told, every signature contains 2 components, S and R. Okay. So the formula for calculating R is G power K modulus P modulus Q. So where K is the randomly chosen key, okay, it should be destroyed after the use. The formula for calculating the signature component S is K inverse into H of M plus X into R modulus Q. Now we have both the components R and S. So they are known as the signature components, and they are transmitted along with the original message. At the receiver end, now we have the message as well as the signature components R and S. To verify the signature, the recipient should calculate 4 values: W, U1, U2 and V. So what is W means? S inverse modulus Q. So S is one of the signature component. Okay. So S inverse modulus Q. And U1 is H of M into W modulus Q. And U2 is R into W modulus Q. And V is G power U1, Y power U2. So G is the global value and Y is the public key. So U1, U2 in the previous steps we have calculated modulus P, modulus Q. Then we compare V with R. If both are equal, then the signature is verified. Okay. So this is the overview. So as I told, we have the global values P, Q, G. From the original message, we have created the hash code. I told in the signature we have 2 components S and R. To create S, we are using the function called F1, and to create R, we are using the function called F2. For both the function, we need the randomly chosen key value. Okay. So what is the formula for R? It is G power K modulus P. So G we have, K also we have. So G power K modulus P modulus Q. Thus R is calculated. Now we move on to S. So the formula for calculating S is K inverse into H of M. So H of M is the calculated hash code, and we have to calculate K inverse. So both are multiplied and it is added with X into R. So X is the private key and R is one of the signature component. Then apply the modulus function. So thus the 2 signature components are calculated, both S and R. Okay. So now we are going to verify the signature. So we have the original message and the 2 signature components. From the original message, calculate the hash code. Okay, I am using 2 functions F3 and F4 to calculate V. Finally, the V is compared with R. If both are equal, then the signature is verified. Okay. So what is F3? F3 is used to calculate the value W. So the formula for W is S inverse modulus Q. So to differentiate the sender side and the receiver side, I have used S dash. But anyway, both are same value. So S inverse modulus Q. Okay. So I have calculated W. So now we have to calculate the signature component V. Okay, so the formula for V is G power U1, okay, Y power U2 modulus P modulus Q. So that is this one. G power U1, Y power U2 modulus P modulus Q. So what is G power U1? So U1 is H of M into W modulus Q. H of M into W modulus Q. Okay. So that is given here. G power H of M into W. H of M into W is U1 modulus Q. Then Y power U2. So U2 is R into W modulus Q. Okay, Y power U2. So U2 is R into W modulus Q. Then modulus P modulus Q. Okay, so we have calculated V. Now both are compared. If they are equal, the signature is verified. Okay, so with this we have completed digital signature standard and the digital signature algorithm. Thank you all.